This is number 2 on the more linear modeling worksheet, which goes with lesson number 7. I went ahead and wrote down the important information from the description here. It says a solar lease customer built up an excess of 6,500 kilowatt hours during the summer using his solar panels. When he turned his electric heat on, the excess began to be used up at a rate of 50 kilowatt hours per day. These are our two numbers. These are important pieces of information. And remember, we are always in this unit working towards y equals mx plus b. Now, it might look different because we're using function notation, but let's go ahead and, for part A, talk about this with y equals mx plus b, and then we'll turn it into function notation. So it said that we had an excess of 6,500 kilowatt hours, and our rate was 50 kilowatt hours per day. Again, rate tells you that's your B. I'm sorry, that's your M. That's your slope. Anytime you see rate, that is a huge clue. So that's going to be our M. So that's going to be 50. For right now, we're just going to leave X and Y, and we're going to change it to function notation in a minute. So if we use 50 as our M, that means 6,500 is going to be our B. Remember, our B value, our y-intercept, is always our initial amount. So in these modeling problems, if you have an initial amount of something, that's going to be your y-intercept. So there we have our equation of our line, and really for us, that's fantastic. You have enough to work with. But let's go ahead and turn that into function notation. The problem for part A says E represents the excess left, and D represents the number of days. So what we're going to be putting in, and our rate we're actually using, and this is something that's super important that we haven't put in yet. We're using 50 kilowatts per day, and we started with 6,500. So we're going to decrease, which means our rate needs to be negative. So we start with 6,500, and after the first day, we subtract 50 kilowatt hours. And the same thing with the second day. We're using 50 per day. So since we're going to have a negative 50 as our rate. Okay, so now let's turn it into function notation. For function notation, we're just going to change our y and our x. It says little d is the number of days since the heat has been turned on. So our x is going to turn into d. And big E is the excess left. And that's dependent on the days. So if you wanted to write that in function notation, all you would do is replace your x with d and your y with E of d. So there's our equation. So let's talk about this for just one more second. We started with 6,500. We're using 50 per day. And our day is our input, and the amount of excess that we have is our output. So that's part A. And now for part B and part C, we're just going to be using this equation. So let's add a slide. So for part B, we're going to start with that same equation that we had. Start with that same equation, and it says how much excess will be left after 1 month, and it wants us to use, for 1 month, use 30 days. So how much will be left after 30 days? Well, that means our input is going to be 30. And now all we have to do is put this into our calculator. Negative 50 times 30 plus 6,500. And when I did that, I got 5,000. And our units here are kilowatt hours. And you can just copy that from the problem there. So if you want to continue with the function notation, E of 30 equals 5,000. So after 30 days, we have 5,000 kilowatt hours left. For part C, let's go ahead and add a slide. Again, I'm going to keep copying this equation because we're going to keep using it. All right, so there's our equation. It says if the heat will need to be turned on for 5 months, will the excess be enough to last through this time period? So we want to know what's happening after 5 months. Do we still have energy left to use? Well, 5 months, we need this in days. So this is kind of like number 1, where we had to make hours or days into hours. So our hours into minutes. Here we're going to make our months into days. And told us in the problem to use 30 days per month. So 30 days times 5 months is 150 days. So that's going to be our input. So let's go ahead and see what we have left, if we have any excess left after 150 days. So we started with 6,500 and we're subtracting 50 kilowatt hours every day. When I put that in my calculator, I got negative 1,000. And again, it's kilowatt hours. Since this number is negative, that means we're actually over. We've actually used up the whole 6,500 and now we're not using any of that anymore. We're drawing from the grid. So it won't last. Our 6,500 kilowatt hours won't last because we have negative output at this time. So it did not last. So we saved a lot of energy, but we didn't save enough energy to offset our costs for the whole winter. All right, that's number 2.